Now, the time comes for calculating the probabilities for non-standard normal random variables. Remember now, our main objective is to solve questions related to normal random variable, whether its parameters are, it doesn't matter. So it may be non-standard as well. Not in all questions we are going to deal with standard normal distribution, okay? In some questions, we are going to see non-standard normal random variables. So we need to learn how we can calculate the probabilities for normal random variables. And for that, we are going to use a standardization operation, okay? Standardization. Let's check the first example. In the first example, it says capital X is a normal random variable where the location parameters is equal to -3 and the scale parameter sigma is equal to 1. So the question gives me the parameters of this normal random variable, and it asks me the probability of this normal random variable to be less than or equal to -3.75. Now, at this format, if I want to solve this probability, I do not have any table regarding to that distribution. I only have a table regarding to standard normal distribution. So what I am going to do is to standardize these inequality. And remember now, the standardization is applied by applying this transformation into both parts of this inequality. So into both parts of this inequality, I am going to subtract the location parameter -3 and the scale parameter 1. To both sides, I'm going to apply this linear transformation. Then the probability statement will become a statement that belongs to standard normal random variable. So let's do that. For part A, my probability statement related to a non-standard normal random variable with parameters -3 and 1 is going to be equal to, after standardization, so to the both sides, I subtract from the both sides, I subtract the location parameter and divide the difference to the scale parameter. And what is my location parameter? -3. When you subtract, by the way, the left-hand side of this inequality will automatically become a standard normal random variable. So this X, this capital X will automatically become a standard normal random variable according to proposition 2. Now the right-hand side will become what? -3.75 minus -3, okay? We say we subtract the location parameter, but the location parameter is already negative. And we divide the difference to the scale parameter, and that inequality becomes the Z standard normal random variable to be less than -0.75. So all we need to do is to identify that value from the table. That's it. Obviously, I'm not going to show this to you again and again, because we have already practiced this in our yesterday's course, also in today, okay? So let me show this for once only, once more, okay? So the probability of Z being less than or equal to -0.75 is what? So let me draw you the picture for that. So let me open a paint file. So remember now, yesterday I have also taught this to you. I'm very sorry for that. So let me, okay. So I draw the probability density function of the standard normal distribution, okay? So I need to draw a symmetric shape around 0 like this, okay? So 0 is here. And what is the probability that I am looking for? The probability of standard normal random variable to be less than -0.75. -0.75. Okay. So I am looking for this area. What is the area here? Now that area is exactly equal to the area on the right-hand side of the positive counterpart of -0.75, which is 0.75. So if I subtract the area on the left-hand side of 0.75, then I would calculate my result, okay? And that is this formulation, and the area on the left-hand side of 0.75 is what? let's check 0.7, and we have 0.05 here, and the result that we are looking for is 0.7734, which is exactly written here. Subtracted from 1, we get the probability. So this is how we are going to solve the probability statements related to non-standard normal random variables. So let's solve another one. So we have a normal random variable with location parameter 5 and scale parameter equal to 1.2. Calculate the probability of x being greater than 4. So let's do that. First, standardize. Okay, first we start by standardizing this inequality, because we can only calculate the probabilities on standard normal random variables. How do you standardize it? By subtracting the location parameter from both sides and divide both sides to the scale parameter. Okay, minus mu divide sigma, minus mu divide sigma to the both sides. So the left-hand side will become standard normal random variable, and the right-hand side will become 4 minus 5, which is location parameter, divided by the scale parameter, which is going to be minus 5 over 6. So the probability of z being greater than minus 5 over 6, which is probability of z being less than 5 over 6, right? Again, due to the symmetricity, just like that. So let me show you the same thing. So this time the question asks us this. We have minus 5 over 6 here, okay? And it asks the probability of z being larger than minus 5 over 6, which is the total area on the right-hand side. And that due to the symmetricity, this total area on the right-hand side is exactly equal to the total area on the left-hand side of 5 over 6. So the result that we are looking for is phi at 5 over 6. Now you need to check this value from the table, and you definitely need to apply a linear approximation, because 5 over 6 is a value which is close to 0.833. It goes like this. So you need to apply a linear approximation for 5 over 6, and you are going to get something very close to 0.7976. Okay. Now, for the third part of the question asks, if x is a normal random variable with location parameter 35 and scale parameter 15, what is the probability of x being greater than 52? Okay. Now, what do you do? What is the golden word here? What is the keyword? Standardize. Okay, standardize. How do you standardize? By subtracting the location parameter and dividing the scale parameter by applying this to both sides. The left-hand side becomes standard normal random variable. The right-hand side becomes 52 minus 35 over 15, the probability of z being greater than 17.15, which is 1 minus the cumulative probability at 17 over 15, and that is 1 minus phi at 17 over 15. Again, at 17 over 15, you need to apply a linear approximation between 1 over 13 and 1 over 13, because 17 over 15 is a number which has infinitely many digits after the decimal point. And in that case, you are going to get your result as 0.1285. And finally, for the last part of this question, do we have a normal random variable with location parameter equal to 4 and scale parameter is equal to square root of 20. The scale parameter is equal to square root of 20. And the question is asking the probability of x to be between 0 and 3. So this time we have an interval probability being asked. What do? You are going to standardize. How? This time you are going to apply standardization to all three parts of this inequality. Okay? So from 0, you subtract the location parameter, divide to scale parameter. Apply the same for capital X and to the 3 value here. And when you do that, the middle is going to become a standard normal random variable, And the boundaries are going to be calculated as minus 0.894 and minus 0.224. Okay, so what is that? What is that actually? So it says we have minus 0.894 here, 894 here, and we have here minus 0.224. Arkadaşlar negatif sayıları sayı doğrusuna doğru sırayla yazamayan öğrenciler de oluyor bazen, biliyor musunuz? Mesela sayı doğrusunda hangisi önce hangisi sonra gelecek, bu sayılardan hangisi büyük hangisi küçük, bunu maalesef bilemeyen öğrencilerle bile karşı karşıya kalıyoruz. Yani bu bayağı eğitimin ne hale geldiği noktasında hani. Evet, peki bu alanı nasıl bulacağız? How do we find this area? By looking at the positive counterpart of it. Because the distribution's PDF is symmetric around 0, we say that we can calculate the area between 0.9800, the area on the left, area between 0.224 and 0.894. So we are going to subtract the CDF value at 0.224 from the CDF value of 0.894. And for both values here, we need to apply a linear approximation to get a more reliable result. And then the result is going to be 0.2257. Okay.